everyone, I'm Jenny Mann, a solutions architect at UiPath. Today we're going to go over one of the most popular products of UiPath, Document Understanding. We're going to talk about what it is and an end-to-end demo walking you through all of the steps from reading in an unstructured document to understanding it and creating a useful automation out of it. If you would like to follow along and get hands-on, you can go to academy.uipath.com to download the workflows used in this video. In the UiPath Document Understanding Overview course on the Academy site, there are additional educational material as well as workflows you can download. And it is also where a lot of the material from this video came from. So let's begin. In this first part of the video, we will go over how UiPath Studio and Robot extract and interpret information using a complete, open, and extensible approach. We will analyze a complete workflow and observe how the 5 steps defining a taxonomy, digitizing, classifying, extracting, and validating the data look like in real time. Let's start by looking at the documents used. We'll be processing IRS forms, invoices, and financial reports. This means that we have structured, semi-structured, and unstructured documents. We will extract data from them all by using one single process. Moving forward to UiPath Studio, we have here a simple workflow. We'll ignore the log messages and the error and exception handling, as these are not the subject of this video. And what remains are the main steps. We start with loading the documents from the target folder and continue with loading the taxonomy that will be used. Then we move on to the digitization, classification, and data extraction. Once the data is extracted, we can validate against the original document in the validation station and correct the mistakes, if any. In the end, the extraction results are saved in the form of an Excel spreadsheet, and we move on to training the classifiers. We reinforce learning on the good cases as well as failed cases. In the project panel, we can see the structure of the projects, the dependencies, folders, and files. The most important is the document processing folder, which contains the configuration files for the taxonomy and the keyword classifier. In this demo, we configure the path to the keyword classifier data in this folder as well, but this file can reside anywhere. It also holds all of the documents that we're going to process and the output folder where the results will be saved. Let's move on and run this whole process on a 10K document. On the right side of the screen in the output panel, we can see the logs in the workflow. Right now, the digitization takes place, identifying all of the text and coordinates from the documents. Next is the classification, identifying the document type, and then the data is extracted. Finally, the validation station opens and we can see the extraction results. Here we can spot that the workflow detected that this is a financial report document and that it retrieved the form type, then the text. We confirm the extraction and we can see the protest going further with exporting the extracted results and training the keyword-based classifier. We'll stop the run now. The workflow would have continued processing the rest of the documents in the same manner. If we refresh the panel in the output folder, we'll find an Excel file containing all of the data that was extracted from the 10K document.
A few moments later.
In this part of the video, we'll look at how to work with the taxonomy, the first step of the Document Understanding Framework. The taxonomy is stored in a JSON file in the document processing folder. To edit the taxonomy, we'll use the Taxonomy Manager, which is a wizard designed to help you define the metadata for document processing. We'll start by creating a new document type for an invoice. From this invoice, we'll extract various fields like the name of the company, which is a text field, the address, also a text field, the invoice number, the invoice date, and this table with the invoiced items. First, we'll create a new group named Accounting and a new category, Incoming. Our new document will be saved under the category Incoming from the group Accounting. Second, we'll create the new document type, which will be named Invoice. If we save right now, we can always edit back by clicking on the document's name. Now we can start adding new fields. The first one is the name of the company, which is a text value. Next, the vendor name, another text value. The third one is the invoice number, which is a number. And we'll also add the invoice date, which is a date value. And now let's create something more complex for the items sold on the invoice. It's going to be a table, and under this value, we can insert different columns. Let's check the invoice. It has columns for description, unit, price, and amount. To create a table value, we add the columns first, the line number. Second, the description, a text value. Third, the quantity, which would be a number type. And lastly, we add the unit price, which is also a number. Now that we're done with the fields definition, we can save the newly created taxonomy. If we close the taxonomy manager and refresh the project panel, we can see our taxonomy JSON file created in the document processing folder. For this training, we'll use a more complex taxonomy. So what we'll do now is to delete the one that we just built and replace it with a new one. All it takes is to just copy the new file into the right location in the document processing folder. Now let's look at the new taxonomy using the taxonomy manager. As we can see, we have multiple groups, categories, and documents defined. Looking at the invoice that we've previously defined, we can see that now it has a lot more fields. Also, we have taxonomies created for the other documents that we will process during this training. For example, the W-4 form. But anytime we can simply click on a field and edit its name or its value, delete it, or create new fields. Now that we have our taxonomy in place, we can start building the actual workflow. We start by adding a sequence and naming it, Document Understanding. The next thing we need to do is to add the load taxonomy activity. This activity already knows which file to load, and from which folder. It just needs to load the configuration file into a variable to be used by the future activities. In our workflow, we have to edit the output property and create a new variable by hitting Ctrl+K. And that's how you work with taxonomy. The next steps are loading the documents to be processed from a specific folder and applying each step of the Document Understanding Framework, starting with digitization. In this part of the video, we'll look at how to digitize documents, which is the second step of the Document Understanding Framework. Let's take a look at our workflow after the load taxonomy activity, which loads the taxonomy JSON file, stores it in a variable, and passes it to the next activities. We've added more functions. First, we have an array of strings named path that stores the paths of the files to be processed from the project folder. Second, we have a for each loop to iterate over each document. Next, we read the name of the document, extracting it from the document path. And finally, we log a message on the info level stating that we run the workflow for the current document in the loop. Now we proceed further with the digitization. We'll add a new sequence and rename it Digitization. And for the sake of project organization purposes, let's add a new log message on the info level that will say that we're digitizing the document. The activity that helps us with the second step of the framework is called Digitize Document, and it requires a couple of parameters to be set up, one of them being the degree of parallelism, or how many pages should be processed in parallel. The magic number is -1, and it instructs the Digitize document activity to process as many pages in parallel equal to the number of available CPU cores -1. If we set it to any other value, like 4 for instance, it would attempt to OCR if necessary 4 pages in parallel at any given moment to speed up the processing time. We'll stick to the default value of 1. We'll use as the document path the variable that stored it in a previous activity, and this output will create 2 new variables. One for the document object model, the tree-like structure describing the structure of the document and its content, and one for the document text. The only thing left to do now is to add an OCR engine. We'll add the OmniPage OCR activities package. The OCR activity will be used for digitizing any image or PDF page that contains scanned content. At this point, the digitization step is complete. And that's how you digitize a document. The next step is passing the outputs of the Digitize document activity, the document object model, and the document text variables to the next document understanding activity, which is classification. And we'll identify, based on the taxonomy, the document types that we're working with.
A few moments later.
In this part of the video, we'll look at how to classify documents, the third step of the Document Understanding Framework. Up to this point, our workflow contains activities that load the documents, paths, load the taxonomy, and iterate through each document to apply digitization. The next step will be to perform the classification of the documents. We'll add a new sequence and rename it classification. For the sake of project organization purposes, we'll add a new log message on the info level that says that we're classifying the current document. The activity that helps us with the third step of the framework is called Classify Document Scope, and it requires a couple of parameters to be set up. First, we need to add all of the variables created by the previous activities: the document object model, the document text, the document path, and of course the taxonomy. It seems that we can't add the digitization outputs. We need to update their scope in order to be able to use them in other sequences. So we'll return to the digitization sequence and update the scope of the outputs, the DOM, the text variables, to the body of the for each loop. Now we can go back to the classification scope activity and add the digitization variables and the taxonomy. We create the classification output a new variable by hitting the Ctrl+K keys and naming it. Classification result, we'll name it. You'll notice that the output of the classified document scope is an array of classification results. This is important because some classification algorithms can report multiple classes within the same file. For example, a file might contain the word contract from page 1 to page 6 and the word invoice from page 7 to 8. We're not handling such files in this particular demo, but it's important to understand why the output is an array. The classified document scope can host multiple classifiers, but we'll start with a keyboard-based classifier. This classifier performs the classification based on specific words that we expect to encounter in each document type. The classifier takes the form of a JSON file, which can be saved anywhere, but we'll store it in the document processing folder. So let's do that and create a new empty JSON file and name it classifier. Now back to Studio. If we refresh the project list, we will see the newly created file. So all that's left to do is to specify the path to the configuration file in the classification scope. At this point, we can start configuring the keyword-based classifier by selecting Manage Learning. In this wizard, we can define specific keywords for each document type defined in the taxonomy. For example, for the invoice document type, we can define variations of the word invoice. If we go back to the text editor where we have the classifier JSON file open, we'll be prompted with a message saying that a change has been detected. We reload the document and we can see that for each document in the taxonomy, we have a structure defined, and the only keywords are the ones that we just set right here in the accounting group incoming category. The invoice document type has to find 3 keywords variations of the word invoice, just like with the taxonomy. We can simply replace this keyword classifier with one that is already configured. So we open the project folder, delete the classifier previously defined, and copy the classifier that we will be using further in this training. Looking at it, we can see that in financial reports, we're searching for words like 10K, 10Q, W4, and variations on them. Now we can move to configuring the classifier. In the Configured Classifiers wizard, we can enable the classifier for each document that we're processing. We do this by checking the box next to the document type that we want to enable this classifier for. As stated before, we can use multiple classifiers, so let's see how that works. We'll add, for this example, the Flexi Capture classifier and enable in parallel both classifiers. We won't go through the configuration of the Flexi Capture classifier, we'll just look at the scope configuration. Opening again the Configure Classifiers wizard, we have the keyword-based classifier enabled for all of the document types. We can enable the Flexi Capture classifier in parallel with a keyword-based classifier or a standalone for a specific document type. If we were to have this diverse configuration, the Flexi Capture will search for the invoice document types, and the keyword-based classifier will search for the financial reports and the W4 forms. An important feature here is the minimum confidence level. We can enable both classifiers for a specific document and define a confidence threshold for each. Let's say 80% and 0. What that means is if the keyword-based classifier has a confidence higher than 80% that a particular document is a financial report, it will classify that document. And if not, then the task of classifying the document will fall on the classifier with the next confidence level, the Flexi Capture classifier. Cancel and delete the Flexi Capture classifier. Its only purpose is to demonstrate how the Configure Classifies wizard works with multiple classifiers. Let's check if we indeed have the keyword-based classifier enabled for all of the document types. Some classifiers will have the capability of learning from human feedback, and we can do so by training them, but we'll see how we can do that later. And that's the third step of document understanding, classify. The next step is passing the outputs of the classification activities and all of the previous activities to the next document understanding step, which is data extraction.
2,000 years later.
In this part of the video, we'll look at extracting the right data from documents, the fourth step of the Document Understanding Framework. So far, we implemented the digitization and classification sequences, and we defined the taxonomy before moving to data extraction. The workflow also contains an if activity that checks if we have a valid classification result. If we do, we have a log message activity that records that we're extracting data from the current document. If we don't have a valid classification, we log that the document could not be classified, and the data extraction is skipped. Next, we add the data extraction scope in the then field of the if activity and set up the parameters. As a side note, as you might have noticed throughout the Document Understanding Framework, the scope activities properties follow a pattern. We add the outputs of previous scopes and create a variable to store the output of the current scope. So let's do just that. First, we add the path to the document, the taxonomy, the document text, and the document object model. Second, we add the first classification results because this variable is an array of strings storing the classification results for each page of the document. Since we added the classification result, the document type ID as found in the taxonomy is not required. We close the setup by creating a variable to hold the extraction output and changing the variable scope to the body of the for each loop. And that's it. That is the fourth step of the Document Understanding Framework, extract. Next, we'll look at how to configure and use different extractors.
2,000 years later.
In this part of the video, we'll look at how to validate the classification of the documents and extraction of the data, which is the fifth step of the Document Understanding Framework. During validation, we compare the extracted results with the original document and make the necessary corrections. We start with exception handling and we add a try-catch activity because the human validation step can report a business exception that we should catch and treat separately if necessary. We also want the workflow to continue with the next document in line, even if a certain incoming file is reported as a business exception. So let's go on and add a try-catch activity that will rename to validation station. Inside the try section, we add a sequence. Let's name it open validation station, and we add a log message activity to record that we're opening the validation station for the current document. Finally, we add the present validation station activity and start editing the parameters, most of them coming from previous activities. We have the document path and text, the document object model, the taxonomy, and the automatic extraction results. Of course, the output will be saved in a new variable named validated results. And let's not forget to update this variable scope to the body of the for each loop. In the catch section, we'll catch system exceptions and add another sequence where we can assign two new variables. One of them will store a validation station error, if any, and it's a Boolean variable. We update the scope here too. And the other one is a string storing the exception information. Also, the scope of it must be the body of the for each loop. Finally, we assign a value of true to the validation station error variable, and to the exception info variable, we assign the exception stack trace value. That being said, we finish configuring the validation station, and now we can run the workflow to see what happens in the output panel. We can see that the execution started. The first document processed is a 10K, which is now digitized and classified. Keep in mind that some of the steps are more time-consuming than others. The data is extracted, and at any moment, the validation station will pop up. Let's take a look at the interface. It's similar to the form extractor wizard. On the right side, we have the original document, and on the left side, we have the document type and the fields to find in the taxonomy populated with the extracted data. For this document, we configure the regex extractor to retrieve only the form type. Moving to the extraction results, we can say that first, the document was classified as a financial report, which is correct as we have a 10K form. Second, the form type 10K was also correctly extracted. Every time we click on a field, the area from which the value is extracted gets highlighted in the original document. For this demo, let's assume that the form type was incorrectly extracted. Let's say it should have been a 10Q document. We can then manually correct it, and the result of the validation station will contain the corrected value. But for now, let's stick with the correct value and save the document. Now we wait for the next document, a 10Q, to be processed. So the results should be similar to the ones that we just examined. The only difference will be the form type value. Now that the validation station is open, we can confirm that the values were correctly extracted. We save this document and continue with the next document and invoice. We set the machine learning extractor to get data from this document type. We see that the document was rightfully classified as an invoice. The name was identified correctly, and all of the other fields matched the documents. Finally, we have a table of items with some values identified. Now, from time to time, errors can slip in, but whenever we find a mistake, we can correct it, confirming that it's missing or add a value. Saving this document, the execution starts processing the last type of document, a W4 form. This document will activate the form extractor. As with the previous documents, the document type was identified correctly. The first name, last name, social security number, address, and town values match the document information. The right checkboxes are selected, and the rest of the information seems to be correct. We can save the documents. The output of the validation station activity is of the same type as the automatic extraction results and contains all of the information confirmed, added, or modified by the users during the human validation step. If we encounter an exception, it will be caught by the try-catch block, and these two results will tell us an exception took place and what the exception was, so that we can add the reported documents to different exception processing queues based on its content. And that's the fifth step of the Document Understanding Framework, validates. The next step is passing the output of the present validation station and exporting the extraction results, and then finally training the classifiers and the extractors.
One eternity later.
In this next part of the video, we'll look at training, how to train the classifiers used in the workflow to make more accurate classifications. After implementing the validate step of the framework by adding the validation station to allow users to correct the extraction results, we stored the output in the validated result variable. Next, we created an if that checks if we had validation errors, in which case we log the error message and continue with the next document. But if there are no errors, we move on with our workflow and export the extraction results in a dataset. This dataset later gets written into an Excel file. If a document wasn't properly classified, it's because it was unknown to the active classifier, so we need to train it. If a document was properly classified, using the training feedback loop will ensure that the classification algorithms can gain more confidence in their predictions. To do that, first we add a new sequence, name it, train classifier, and add a log message to record that the workflow is training the classifiers for the current document. Second, we add the train classifier scope, and we start editing the parameters like with all the intelligent OCR activities. We add as input variables the stored outputs from the previous steps. We add the document path, the document text, the document object model, and the human validated extraction, because in the classification step, we use the keyword-based classifier. This is the one that will train, so we drag its trainer inside the scope and specify the training file path. Remember that we saved the keyword classifier JSON file inside of the document processing folder. We'll use this file. The next step is to configure the classifiers that we want to train. We use the keyword-based classifier to find the financial reports, the invoices, and the W4 forms. We'll check all of them for this demo. Now we can start managing the learning. To see how it works, we'll remove the W4 keywords. On the next run of the workflow, the robot will encounter a W4 form which it fails to recognize. So we'll train the classifier. On a later run, after training the classifier, the robot will be able to recognize it as a W4 document type. So let's run the workflow. We can see in the output panel that execution has started and the W4 form is digitized. The robot will try to perform a classification that will fail. And now the validation station is opening and it will show us it wasn't able to classify it. As we can see, the validation station looks different on the left side. It has only one field, the document type, and it prompts us to select it. You will see that this is a W4 document, and now it asks for evidence. We provide it by clicking on a W4 word. We can make multiple selections by holding down the Control key. After the selection, we go and choose Change Extracted Value, save it, and the workflow continues the process. Since this was the last document in the Documents folder, the execution ended. And if we open the Managed Learning Wizard, we see the values that we inserted earlier for the W4 form. Let's run again the workflow only for the W4 document. The document is being digitized, classified, and this time the robot identified the document type and it extracts the data. The validation station opens, and we can see that the document was correctly identified, and the fields were also correctly matched. If we save, the execution will continue and end shortly after. And now we have a complete document understanding framework up and running. If an unknown document is encountered, we'll also have an exception handling mechanism in place that just logs the error and moves to the next document in the queue. The extraction results are saved in the Excel file that we see here in the folder. And this concludes our demo on training the classifiers used to recognize unknown documents. The next step is also to train the extractors following a similar process. All you need to do is insert a train extractor scope activity, and within it, put all of the extractor training activities configured accordingly based on what your use case needs. In this example, we don't use any extractors that we want to train, so we'll skip this step. So that's it. That's a complete end-to-end document understanding framework that we've just built and follow along on each step of the way to implement it end-to-end. I hope this helps. Thanks for watching. Subscribe to this channel for upcoming content on how to start or build a career in tech, how to automate using low-code RPA, how to build real-time low-code data pipelines, and other tech content.